In monolithic applications, right, when we compare microservices with monolithic, so far we did monolithic scenarios only. So in monolithic applications, we do implement applications in a modular fashion. We will implement all the modules of application into a single application. As a single deployable unit, we uh, create the application, right? So when we say monolithic, it is a single deployable unit, right? So we will have only one deployment. When you say I want to deploy monolithic application, only one deployment is enough. But in case of microservices, you will have lot of services. As and when you create a new service, that new service only you deploy. Or if you want to manage, or if you want to do modifications on the existing service, you can modify and you can deploy that particular unit. That means from the deployment, the other services are exempted in the microservices scenario. Okay, so in monolithic, though you did modifications for storefront or accounting service or inventory service, whatever it is, as I have multiple modules, if I do small changes in the shipping service code, still you need to deploy the entire modules code. All these modules you need to again redeploy, and once application come to the live, people can start using it. But that will not happen in microservices. Let's say you implemented multiple services, as multiple services, delivery, order, consumer, as a small microservices. If you found problem in consumer service, you need to only redeploy consumer service only. Okay, you developed with independent teams. I have, independent teams, they can able to design this application parallelly, they can deploy them also parallelly as and when they want. They can maintain their respective modules also. Consumer team responsible for consumer service, so they can modify as per requirements, right? As and when consumer service changes are required, they go to consumer service, they modify it, they redeploy it. That means you need not to redeploy your entire system, you need not to touch other infrastructures. There will be lot of things that we will involve in microservice. Lot of services will involve. That means all that services need not to be redeployed, only your particular service need to be redeployed, and you need to bring it into live. Guys, go to mute if you are not talking. Shiva. Yeah. Yeah. So okay, we understand it pretty much well, how to what drives through making microservices. And coming to microservices, as you think, okay, they are smaller in size. Again, it's depending on the service. Okay, but but people are recommending, whoever uh, a part of microservices, what they are recommending it is reduce the dependencies of other services. If you have too much dependencies, you please avoid that and create it in a single application. During microservice design, right, I want to create a microservices application. What are all that factors that we need to keep it into the mind, right? Yesterday already we discussed, right? So your microservice should be smaller in size. It should be smaller in size, independent deployable, smaller. It should be smaller in size, it should be independent deployable, it should have new database, new repository, or its own repository, new, or you may call own database. It should have its own database, it should have its own repo, and it should have CI/CD, right? So you need to keep all this in mind. Without CI/CD can't I do means you can do, but no use. When you increase your microservices count to hundreds, physical deployments are not possible. So you need to use automated pipelines only. So you need to have such a teams to create them. Right? You need to keep all these into mind. It should be smaller in size, independent or deployable. It should have less dependency with other modules. Yes, you can have dependency, but it should have comparatively very less dependency. You should have very less dependency with not modules. See, I am using modules with other services. Less dependency with other services. And you may have same team or independent teams also can work here. Independent teams can work on it, but if you have a simple a small team, if they are responsible all microservices, still it's okay. But usually if you have independent multiple teams, it is more helpful. They can parallelly deliver multiple microservices. Independent teams you should have. And you should maintain this microservices from right. You need to follow some technical. When you create microservices, you should able to manage configurations centrally, here. You should have configurations stuff inside your microservice. You should have some central server, from there you should able to manage it. Otherwise it will mess up your microservices management. If you create lot of microservices and if you keep configurations within the microservice itself, tomorrow if you want to change something, you need to visit each microservice and you need to do the changes. So that is very bad way. So you should manage configuration centrally. I'll explain through architecture, okay? And you should use gateway for communication, gateway as a mediator. You should use for communication, as a mediator for communication. Directly you should not talk with anyone, via gateway only you should talk. So the gateways are required here. Apart from that, there are some other beauties you can add, but these are the minimum things. Apart from this, a microservice can have so many additional features, but at least if you are creating a microservice, at least you should follow all these. To create a microservice. Yeah, one more important thing I missed. You should provide documentation also. API documentation you should provide. We should provide API documentation. Once you're done with your microservice application development, right, you have to provide API documentation using Swagger or any such UI tools. They will generate API documentation for your methods. Okay, so about Swagger we need to see. Okay, we will discuss that. So if you can provide API documentation of your microservice, if someone wants to know If someone wants to know order service methods, what is the input will take, what is the output it will give, if they want to know, they should not ask order service team. They will not interrupt, or they will not, you know, ask team, can you explain what are the inputs, what are the outputs. They need not to approach them. They can directly refer the order service documentation. Maybe they are different teams, but they are part of the same company. They may maintain these applications or this microservices data somewhere in a Confluence pages. Somewhere they will put, this is what my order service API, you can refer this API for more insights, what is the input, what is the output, so that other teams can able to refer that API documentation, and they can understand what is the method input, what is the method output, right? We need to know about each service, what as a input it will take, what as a output it will give. That is also very important. So Swagger documentation, you need to provide some kind of documentation. So which is Swagger we will use. So these all are the minimum that you need to provide. Minimum that you need to provide. So when you are creating a microservice, you need to keep all this in mind. What you need to keep it in mind? If the functionality is very larger, you need to think immediately, can't I break it into multiple microservices? Yes. Okay, I am breaking them into multiple microservices. They are independent deployable. Or if you found dependency without this logic, or that logic I can't able to deploy it, so then make it as a single microservice. So if you can create it as a smaller size, a simple service, it should be independently deployable and manageable. If it meets all that, then create it. And it should have its own database, and it should have its own repository. If you don't have database, immediately ask your team. Ask your team or your technical lead, or you may reach out to your DevOps team. Ask for a new database. Man, I am creating a new microservice. Please create one database instance and share it with me, username and passwords, so that I'll start working on it. So when you ask, he will create one development instance, one SIT instance, one UAT production. Lot of instances they will create upon your request. Same way, you can ask for repository, and you can keep your code in that repo. Or if you have single repo, create a new branch. It's always good to have a new repo. Okay, it's always good to have a new repo instead of you creating branches. So always let's create a brand new repository in your Git or Bitbucket. And meanwhile, you can ask your CI/CD team to set up CI/CD for your deployments. So they will understand behavior of your application, and they will set up all the necessary integrations. And you should not have much dependency, right? Why we are mentioning it is, it should be independent, always loosely coupled. Yesterday we were mentioning, right? It should not have much dependencies. In case if you have, it's okay, you can able to exchange communication between multiple services. So you should have autonomous teams to work on each microservice. So that's how parallelly we can able to implement any number of services. And centralized configurations you should have, either you use from cloud or you built on your own. You should able to manage centralized configuration. Why it is really needed is, if you have 100 services, for 100 services, if you have configurations in local each and every microservice, it is difficult to manage. Let's say you are technical lead and you have 10 teams under you. They are creating hundreds of microservices, but you don't know for which service, which configurations they have used, which username passwords they have used. In future, if you want to do any modifications, or if you want to make any changes, you don't know where to go and what to change. But if you have a centralized server, you can go and directly check what is there in or what properties they are using, and you can easily manage them. Upon changes in the configuration server, it will do reflect in your microservices, so that it will be easy to you if you have some centralized configurations servers. So that also you need to manage. And gateway is mandatory. If you want to talk your service with others service, or if they wanted to talk with you, or front end wants to talk with the back end, for any kind of communications we need to keep gateway in middle. Without a gateway, directly we should not share our microservice URLs with anyone. So the gateways are important. And you need to provide API documentation also, because there is a front end team, they wanted to understand your backend implementation. Let's say you created a registration page or login page, they should understand what is input for the registration method. ID, name, email address only you are using, or any other additional parameters are using, how they know about it until unless you tell them. So instead of you telling them, provide a API documentation. Just by looking into this documentation, they can understand, okay, this is what input for his method and this is what output of his method. So by aligning that input and outputs, I need to create my UI page. They understand it easily, quickly, and even they can test it also via this API. Even if you have backend testers, if they want to test your application, they can easily test it. They can able to test it. So it should be testable also, not only in deployable and all, it should be testable also. You should able to test it. So the component should be completely testable. You should be able to test it. If it is not testable, how you deploy it into production without testing? All testings you should pass, right? So it should be independent testable. How you create that during CI/CD, right? If you write any test cases which are depending on other microservices, if those microservices are down, your CI/CD may fail. So for test cases also, right, by keeping it into mind, Mockito based test cases are very important here. Okay, so Mockito based test cases are very important. Why? Because if your service wants to make calls with another microservice, okay, you implemented it perfectly, you created A microservice and there is a B microservice, both are running perfect. So when you test A microservices test cases, it connected with B and it executed perfectly. But somewhere in the deployment in SIT or UAT, again it started testing, and by that time UAT instance is down of other microservice. So obviously your test cases will fail. So your application is not deployable because of others microservices, because you kept some tightly coupled test cases there. Instead of that, you go with Mockito based test cases. In Mockito we don't put any strict conditions. We create, instead of strict conditions, we create mock objects, so that mock objects will behave like a other XYZ microservice and they will provide the mock responses. Okay, so it's always good to create your testing components with the Mockito instead of plain JUnits. Okay, so that is also you need to keep it into mind. And other features like load balancing, resilience. Okay, your application should be having load balancing. In case if you are getting heavy load, you should be able to balance the load. More resilience. Okay, so more resilience. So for that we have pattern also here. Where is that? Yeah. Okay, so for more reliability we will use circuit breaker principles here. Circuit breaker, will help you to understand if there are any failures, right? So it can able to do some kind of rehits. Okay, more reliable. In case I did one hit, it failed, it should not throw the response back. Maybe it need to wait for some more time, and it should again reheat. Why really we need to do that? Because in monolithic we don't have that problem. When we have modules, directly one module will interact with other module and we can ensure the response. But in microservices, I am making a call from my A service to B service. I don't know, B service may be in a problem, or B service may be having a huge load this time. Instead of concluding that B service has failed, I should wait for some more time and again I should reheat it. Actually customer will not do that. You need to do that in your code. Okay, so by using some useful concepts, we do that. We do reheat it, and we'll understand if there is a problem. We'll give some more time, and again we do rehits up to some time. And still if we see after one time or two times or three times if it getting failed, we will conclude it, okay, that is really failed, and we will send failure response back. And what else? And you should, one more important thing that I missed here. Okay, make it as a, of course, 14th point, but important. You need to log centralized logging. Again, it is important. You need to put it logs in your code anyway, that we can do, but you need to centralize them. Centralized logging is important because hundreds of microservices I have. Somewhere it failed. Into which microservice I should go and verify it, which is failed? I don't know that. When it is going in a chain from A service to B, B to C, C to D, like that, I don't know in that flow where it is failed, how it is failed. If I have a centralized logging dashboards, I can go there and put my exception message, whichever exception I received, and I may see that particular time what are all errors applications produced, all the applications produced, and from that errors I may understand what happened to my microservices. You really don't see it as a problem in monolithic, in a modularized fashion, but in microservices you should ensure everything. Right, you can't rely on others modules. They may work or they may not work, other services. So carefully you need to configure everything during your test cases designing, or during your service to service calls. And logging also, you need to keep logs, so that if something failed, by looking into the logs I can able to understand what happened to my microservice, so that I can able to address that issues. Okay, if we found anything across, later we will add them here. Okay, we'll add them here. Yeah, Now let me draw a simple microservice architecture, how we will implement it. How we will implement it. Consider the same e-commerce as an example. You can easily understand. I have a customer module, so I decided to create it as a customer microservice. And I have an inventory service, okay, or product service, to create all the products and manage. And I have a delivery service, and tracking service. Imagine everything. If you can create it as a microservice in e-commerce, you will be having thousands of microservices here. Consider these many microservices I am creating. Okay, during this microservices creation you need database instances. As I said, right, you need database instances and repositories. So for each you need to have one database instance. I have one database here for customer service. So you need to have one database. So customer service will deal with customer database, product with product database, delivery with the delivery database, tracking service with tracking database. You need to have independent databases. And as I said, repos also you should have independent repos only. Coming to configurations, these all services need some username passwords. If you imagine this database instance names and username passwords of these databases, you need across all the services. So if you want to hide from these services, or if you want to centralize them and manage it from a single service, you can do that. We have cloud config concept in Spring. How it helps is, we can have one more service here, config server. Concept name is config server. Cloud config server we will use. So using this cloud config server concept, we create a one configuration service. Again, this is also one service. Everything we create as a service only, like how you create your custom service, product service, delivery service and all. Cloud config server, what this config server will do, it can fetch properties from any central repository. Consider you want to maintain username passwords. You can maintain it from your Git repository or Bitbucket repository or any SVN, any source control tool you can use. There you can keep your username passwords. Or I am using cloud, sir, I don't want to keep my properties into Git or Bitbucket. So you can use any cloud vault services. You can use any cloud vault. You can use any cloud vault services, VOLT I believe, yeah, anything. Cloud vault secrets, all the secrets we can put it into vault so that nobody can see them. So now you can connect your config server with the cloud vault, or you can connect with your Git, fetch your properties. What we put in this SVN or Git project or in this cloud vaults, your secrets. You can put all your secrets here. You can keep all your secrets here so that nobody will see that. I have access to my secrets, so I can go and check them. I can modify them. Now this what can be part of the secrets? You may have your database configuration properties, username password stuff, DB configurations you may have. If you have Kafka, some kind of stuff, Kafka configurations you might have, other services details you may have. You may have anything that you want to maintain as a property. Simply we used to maintain in local, right? Instead of local we maintain from centralized server. You can configure anything that will be loaded into your config server. From config server we refer it in our microservices. We read from config server. So during writing my service code, I don't directly put any properties in my own. I'll refer it from config server. I'll refer it from my config server. So config server will provide all the required configuration details to me. If I hard code locally, we understand that is creating a problem. In future, as a lead, I want to go and modify some services configurations, so I need to edit them and modify, I need to redeploy. That's a big difficult part to me to organize my services. Instead I go to this centralized configurations and I can easily modify them, so that will be reflected immediately on my microservice. Maybe a simple restart is sufficient. Yeah, this is one important thing. And I want to connect with other microservices or front end also. I have here, I have front end, some Angular or React front end I have. Or some mobile UI, mobile client, or some Java client, anybody, any client you may have. They want to talk with your microservices. Maybe it can be a UI or anything, a standalone UI or Angular, React, mobile, anything. They want to talk with your microservice. When they want to talk with your microservice, you should not directly allow them. Instead, what you can do, you will have a gateway. Very important in microservices. Gateway is very important. So you need to create one gateway, or you should use existing gateways. We can create, or we can use cloud gateways also. Okay, we have cloud option also. Cloud gateways also available. If you are using any cloud and if they are providing you a cloud gateway, you can use that. You need not to create your own gateway, or else you can create your own gateway service and use it also. But one is important, either your gateway or cloud gateway. Any request which it wants to connect with the backend, it will come to gateway only. From gateway, it helps to forwarding that request. From gateway, it helps us to forward the request. gateway can also work like a filter here, right? If any request coming to the gateway will verify it, like a watchman or a gatekeeper, how he will verify if anybody entering into our apartment. He will check, do you have approval mail, or he may call us and ask, somebody came to visit you, shall I allow or not? Gateway can also do all that stuff. There can be many clients, maybe your trusted clients or untrusted client request also you may get. Somebody noticed your URL, and if they try to hit, that URL should not allowed. That's where gateway will help you a lot. First, any request, we don't show our URLs first to anybody, we don't share it. If anyone wants to connect, they will connect with the gateway URL only. They will have only gateway URL and they will hit gateway first. Gateway verify each and every request. You can verify actually, not by gateway. You can write security code here. You can verify security, whether that request is authenticated and authorized request to go back to my microservices or not. If it is authorized, then only gateway will allow. If you configure in such a way, then only the request will come to your microservices, so that you can safeguard your code or your service. Without gateway, the problem is, okay, in gateway we discussion we do that, but on high level, without gateway, when you want to share your service with front end teams, right, you need to share your service URLs. In local, I deployed in so and so server, this is the server URL and port. About your SIT URLs, UAT, production, do we need to really share all that stuff with other teams? No, we should not. So there, what we do, instead of that, we configure our URLs into gateway. Excuse me. And gateway URLs only we share it with the front end team, with our application extensions. If they want customer service, they will call /customer/ something, your API method they will call. So once it comes to gateway, gateway will understand, okay, he wants to deal with customer service, okay, let me forward it to customer. Any request, it will go via gateway, come back via gateway. So we can have one more service, which is gateway service, which is very important to enable security to our microservices. Gateway is plays very important key role. Very important key role it will plays. And one more thing, okay, I created my services and configured it in gateway, everything is working fine, but sometimes I am getting huge load to my customer service. Okay, so during Saturday, Sundays, many customers are placing orders, so my customer service feeling very load. I am seeing the graph in the customer service, almost it is consuming all the RAM size, and almost like thousands of requests I am getting there. So maybe if I continue further, it may not able to handle if it exceeds the users count which I am receiving as of now. Maybe from next month I am going to get lot of customers, new customers, because I am promoting my product, so lot of customers may interact. How I can balance that load? Yes, so instead of running in one port or one server, you can run your customer service in multiple instances. Okay, for India customers, I want to run India service, for China service, like that. For each country I want to, or I want to run 10 services randomly, each service need to be executed, so that I can able to balance my load. I'm getting 100 customers, if I distribute 100 customers 10 to each service, easily it can able to handle. Can I able to handle that here? Means yes, you can use a load balancers also here. We have Eureka, load balancing. The advantage with the load balancer is whenever there is a customer request or when there is a request from front end or any other services, first it will hit gateway. A gateway will let information from load balancer. It will get information from load balancer. It will ask, hey load balancer, what is the current instance that I need to request, which are all busy and which all are free. Eureka will help. My customer service is running in port number 8080, 8081, 8082, 8083, 8084. In multiple ports my customer service is running in so and so machines or in the same machine. We do register all these ports into Eureka. We will let this information know by Eureka. Eureka will know where your service is running. In such a way we configure it. When you run your application, it will straight away go to Eureka and register there. Hey Eureka, I started my service in 8080, 8081, 8082. Whichever port you start, that go and register there. So whenever there is a request to gateway, now gateway will approach Eureka. Hey Eureka, which service or which port or which URL that I need to hit? Eureka will suggest to the gateway, go to so and so URL that is free for now. That's how it can distribute the load also. That's how it can distribute the load also. Using Eureka load balancer, we can able to easily manage it. And what else is required? Central logging. For that you need to create one log service and keep all the services logs into one central log server. You create it or use any cloud log service for monitoring, right? Logs are very much helpful. Without logs we can't understand if something a problem occurs. Without logs we can't understand anything. So you can create a log service. You can keep every request which is going via gateway, right? You may keep it into this log service so that easily I can verify who came and when they requested it. Maybe your services also can keep logs here so that I can able to easily monitor it. Apart from this, when there is a request that is going across multiple services, I made a request to tracking service, it need information from delivery or product or customer. So one request is going across so many services and somewhere it failed or somewhere it success or somewhere it is tracking or somewhere it is taking more time. I want to trace that. So to trace it also, to trace, right, for tracing we have tracing services also. We can create a tracing service. There I can trace each and every service, how much time it is taking. Distributed tracing. Distributed tracing. Distributed tracing also important. Distributed tracing also important. We use this Joule. Let me show you. Just a minute. Okay, we have tracing service also that we will use. I think name I'm not able to recall. um, that we use it for distributed tracing and tracking. Okay, distributed tracing and tracking we do with the Joule, I think. Yeah, maybe Joule. Sleuth we use. Sleuth. For tracing purpose. Okay, that is simple concept. So what we will do, each and every request we keep it into this tracer, so that when there is a failure somewhere, or when there is a time it is taking from this distributed tracing dashboard, we will understand where actually it is taking much time or where it is failing. That all easily we can able to monitor from that tracing server. So tracing also important, but we don't have all these problems in monolithic, right? Because everything, all the modules are together, so there is no chance of failure. In case if there is a failure also, via logs we can able to identify it. But in microservices, I don't know. Once I submit request, where it will finish, I don't know. I call my service is A and I have dependency with B. I call B service. B service may have dependency with C. C may have dependency with D, E, F. Like that, it may have, unlimited chaining. It may have. We don't know where it will go and how it will fail. So to understand that more clearly, where it is going, how it is going, we will use this distributed tracing to identify that. So these all are the main key components. Okay, along with setting our mindset how to implement microservices, you need to use these configuration servers or load balancers, gateways, logging servers, distributed tracing servers. This all you need to manage. Then only you can able to make a robust microservice. Otherwise, microservices will create endless problems to you if you don't follow all this. So it is very important to use all such components. The main important stuff that you need to do is centralized configurations and gateways. They are very important. Load balancers, it's up to you. Sometimes cloud only automatically will manage it. You need not to really see this, but if you don't have cloud, I have my own private virtual machine. There I want to achieve that. Yes, you can use Eureka. And logs, you can create your own log server or existing cloud log services also you can use here. Cloud also will provide log services. Cloud log services you can use. Every cloud is having its own log service. Best log services they provide, you can use them. Right, for everything from cloud we have solution, as well as open source solutions also we have from Spring itself, from Spring Cloud. I don't have that much investment, I want to manage it on my own. Yes, you can create in simple clicks. You can create one load balancer, one config server, gateway. You need not to write much code, just you need to use that gateway status or load balancing status. That's it, they will provide it automatically. Very few configurations that you need to do. So creating all these is not a big deal, easily we can create them. Okay, yeah. So tomorrow we will start with the microservice. Okay, small microservice development. We'll create microservices with cloud config. Okay, first we will start with config server, then gateway, load balancer, logging, tracing, and these all we will do by keeping microservices patterns into the mind. Okay.